Hello! Welcome back to the Terra devlog, a survival and exploration game set on your very own planet. It has been quite a while, I'm sorry about that, but I'm still working actively on Terra though, so don't worry. It's just been a lot of other stuff happening at the same time, like work and moving to a new city, and this next part turned out to be quite challenging, so it took some extra time. But this episode and the last few months has been all about biomes. And if you're a member of my Discord server, you might have seen some screenshots of what I've been doing, and if you're not, remember to join with the invite link in the description. In a lot of areas, this last biome adventure has been a classic case of 1 step forwards and 2 steps back. But a lot of the time, that is the reality of game development. Sometimes it just takes some extra time to figure out a good architecture for all the underlying systems, so that further development becomes quicker. In earlier videos, you have seen my planet basically split up in 3 different biomes. We have the forest biome, where I spend most of my time, the mountain biome, where I can find rocks and caves, and the ocean biome, which is basically just water. But what happens when I want to add a 4th biome and a 5th? To be honest, I have been quite intimidated by the topic of biomes because it's such a big area, and considering my game is completely procedural, I need to make sure that it looks good using only math, numbers and statistics. So in this video I will show you my results so far, but also show you why I don't think it's complete yet and what I will need to do moving forwards. I split the whole biome problem into 4 parts. First, Biome Map Generation. How do I choose what biomes go where on my planet? Second, Biome Topography. How can I make each biome look different from one another? Third, Biome Transitions. How do I make the biomes smoothly transition between each other? And last, Foliage. How do I give each biome unique foliage and spawn it on the biome surface? And of course I have to make sure that the systems for all the parts are modular, but also, most importantly, performant. Because what's the point of having 1,000 different biomes if they make your game unplayable? So let's start with the first part, Biome Map Generation. As in most other areas of game development, the first part of trying something new is to learn about how it has been done by developers before you. So I did a lot of research into how procedural games like Minecraft, No Man's Sky, Valheim and others decide where to place their biomes. And what I discovered as a clever and common starting place for most of these was to take inspiration from the best resource we have on biomes, the Earth itself. And when looking at Earth, we can clearly see some general rules for the climate, such as the closer to the equator you are, it generally becomes hotter, which means we get deserts, rainforests, savannas and other tropical biomes. The closer to the north or south pole you are, the colder it gets. And at the caps, we get large Arctic areas filled with ice and snow. And if you are in the middle of the equator and one of the poles, you get more mild weather, forests, grasslands and more lush biomes. Then we of course have the mountain ranges, which are scattered all around, usually on the borders of where continents meet, and sometimes by the coast. These are all real-world elements we can take inspiration from when deciding where to put our biomes in Terra. And for Terra, I boiled all this down to 3 biome parameters, which would decide the final biome on the surface. We have temperature, which is similar to Earth's, hot at the equator and cold at the poles. And then we have rainfall or precipitation value, which tells us how much rain an area gets. And then lastly, we have the elevation, which tells us where our continents should be, where there should be land and where there should be ocean. And of course, my goal is not to have a perfect replica on how Earth decides its biomes in Terra, but just a little bit of real-world logic goes a long way. And by boiling it down to these 3 parameters for our entire planet's surface, we can make the choice of biome a lot easier. Is the point we're sampling hot, has no rain, and has pretty low elevation? Then it should probably be a desert or a canyon. Or is it hot, but has a lot of rain? Then a tropical rainforest would fit quite well. Cold and high elevation, snowy mountains. Yeah, you get the point. But the way a voxel landscape like this works is that for each point on our landscape, we have to calculate these parameters to find the correct biome. And because of that, the math can quickly build up and impact the performance, even if it's quite simple. So I decided that if I calculate all the biome parameters once at the start of the game for the entire planet surface and store all these values in a big texture, I could use that texture as a lookup map. So instead of doing all the complex biomath necessary every time I want to sample a point, I just sample the pre-computed texture at the planet coordinates instead and get all the information stored in the sample pixel. So to do this, I made a simple data asset containing all the different parameters I would need to adjust how the noise maps should generate. And then when I adjust the parameters, I recalculate all the noise values and store the results in the red, green, blue and alpha channels of the texture. Sure, it lags a little bit every time I recalculate this texture, but that's fine since I only do it in the editor before the game even starts, so it won't affect the gameplay in any way. The red channel contains the temperature, which if you imagine that the top of the texture is the North Pole, and the bottom is the South Pole, and the middle is the equator, we get a nice smooth gradient from black to white, or 0 to 1, where black is 0 and cold, and white is 1 and warm. So the closer to the equator we are, the closer the value gets to 1. Then in the green channel we have the precipitation or rain amount, and for that I made another gradient where the equator and the north and south pole gets little rain and the areas between gets more rain. Then in the blue channel I have the elevation, and this is the map that makes the continents, where white is land and black is ocean. And by adjusting the noise frequency, amplitude and octaves of the elevation map, I can decide how my continents should look. I can also adjust a warping parameter to make some nice variation to the otherwise pretty rounded continent borders. So that's the first texture map, but I actually made two textures. This first one that we just went over contains all the information we need to decide where the different biomes should go, and in this next one I store the actual biome information, which I calculate based on the first texture map, if that makes sense. So in this map I use two color channels. In the red channel I store some more details on how I want the mountains to generate, such as adding some more mountains close to the coasts. Then in the green channel I store the ID of the final chosen biome, or the biome index as I call it. And this biome index is selected from this array of biome data assets. And if I ever wanted to add more biomes to my world, all I would need to do is add the biome to this list and recalculate the lookup textures. If we go into these biome assets, we can see all the information needed to represent this biome, such as what surface material it has and what foliage it has. But we'll get back to that later. What's interesting right now is the part up here called the biome meta. In here I have made parameters to define where each of the biomes are allowed to spawn. With these parameters we can say that we want this biome to spawn when it's hot, no rain and low elevation. And when the biome texture maps are generated, it will get the biome that has the most similar values to the point being sampled and select that as the biome for this point. So now in my voxel graph I can make a custom C++ node that reads from my lookup textures, translates from texture space to planet space, and gives us the information we need to generate the voxel based on what biome it is in. For now let's test this and say that if the biome we get is ocean, we set the surface material as blue, and if it's land, we set it to green. And there we go! We can now see that our texture is mapped correctly to our planet. And if we want to adjust any of the settings, we can simply go into our data asset, adjust our parameters and recalculate our noise map, and the planet updates in the background accordingly. Now we can also give all our biomes separate materials. Then the selected biome material will be applied on the biome surface. Awesome! So far, this biome adventure had been pretty fun. I felt like I had a good solution that was scalable and quite performant. It was easy to customize and easy to add new biomes. But now it was time to give the biomes some custom topography, and this is where things started to become quite complicated. The initial idea of making the topography for each biome is quite simple. Give each biome a set of noise parameters that decides how the noise map making the biome topography should look like. And then blend the biomes together to smooth out the edges. The first step was pretty simple. In each biome asset I've added a section for topography, where we define all the parameters we need to adjust the topography noise function. We have frequency to decide how hilly the landscape is, and amplitude to define how tall those hills should be. octaves to define how many layers of noise we want to add some more detail, and some other parameters to decide how the noise function should shape the landscape noise. Then in my noise function, I simply read these parameters from the biome data asset associated with the biome index of the surface. I can set the mountain topography to generate tall mountains, and the deserts to have low, dune-like sharp hills. And if I want more customization in my biomes, all I need to do is add more parameters to my topography and adjust the noise generator accordingly. So that's step 1 complete. Each biome can now have its own unique topography, and it's easy to adjust through the biome data assets. But as you can see, when two biomes with different topography meet, we get a nasty cut in the terrain, which is neither pretty to look at or natural. So then came the real challenge: blending the biome surfaces together. Let me take you through what I've tried, what I've discovered, and what I ended up with. My first thought was that I could use Voronoi noise to blend the biomes together. If you're not familiar with the Voronoi noise, this is what it looks like. It basically generates these cell-like shapes, where each point is given a value based on how far away it is from the center of its closest cell. And this Voronoi noise is what I use to decide the shapes of the biome anyways, so I hoped it would be simple to adjust it to allow for smooth transitions. In my biome functions, I get the center of these Voronoi cells and sample that position in my biome lookup texture. This sample will then give me a biome index, and then the whole Voronoi cell is generated with this biome index. As I also mentioned, when sampling any point with Voronoi noise, I can also get the distance this point is from the center and to any neighboring Voronoi cell. My idea was that I could use this distance value to determine how much weight any of the neighboring biomes has along with the center biome. This means the closer to the edge I sampled, the less weight the center biome has and the more weight the neighbor cells has. Then I would sample all the biome noise values of all the relevant neighboring cells and use these weights to determine how much of their noise values would affect the noise value of the current position. It sounded a bit complicated, but in theory, logical and doable. So I gave it a go. And in theory is keyword here, because in practice, it sort of worked, but it gave me these really annoying sharp artifacts on the edges of basically every Voronoi cell affected by the biome transition. I think that my issue is that my mind usually always tends to think about noise maps as 2-dimensional, but the Voronoi noise that I'm using for my planet has to be 3-dimensional, since it's a volumetric planet and not a flat landscape. Keeping this in mind, I tweaked the transitions a lot and found tons of unique biome transitions, such as this method, which made a lot of spot-shaped artifacts all over my planet, or this blocky transition, which was pretty cool. But my favorite has to be this bubble transition, where my entire planet turned into a bubbly ball pit. Also quite cool, but unfortunately not exactly what I'm looking for right now. Then I made this transition, which filled my planet with craters. Perfect for a moon, but not what I needed. But actually, if we increase the biome size on this one, it kinda worked. It's just a little too many artifacts for my liking. I also would like to have pretty small biomes, so if smaller biomes meant craters, it's a no for me. So I switched up my tactics. I decided to take another approach by just using a Gaussian blur to blur out all the values across larger sections of my landscape, like that Gaussian blur filter you see in Photoshop. And this actually worked! By applying a Gaussian blur effect to the surface, I got the smooth transitions I was looking for, with very minimal artifacts. I was so surprised and so tired after trying for weeks to get the previous method to work, so this was really a welcome surprise. I still would absolutely not call it a perfect solution though, as the Gaussian blur is really expensive and does affect the performance of the voxel landscape quite a bit, as we need to sample a 5x5x5 area around my point, making a total of 125 samples for each point, which is not optimal at all. To be honest, the other method would also affect the performance a bit, but a little less than this Gaussian blur one. So yeah, not optimal, but for now, I just needed to get past biome blending so I could continue making this video for you guys. If any of you have any suggestion on how to solve this, please let me know in the comment section. I would really love to see more feedback on this and explore alternative methods for improvements later. But now it's time to look at something a little more interesting: foliage. Now that we have successfully smoothed out our topography transitions, it's time to fill our biomes with foliage to really make the different biomes stand out. For this, I decided to use the new Unreal Engine framework PCG, or Procedural Content Generation framework, as this has runtime generation built in, and the voxel plugin has support for scattering PCG points on any voxel surface. PCG is also the system I already use to scatter my foliage, so a lot of the setup is already done. And how PCG works is that it basically takes your terrain and scatters a bunch of points all over the place. Then you can spawn meshes on those points, such as trees, grass, flowers, and so on. But from the point is generated and to the mesh is spawned, you have to adjust the attributes of the points. Like for starters, you of course have to tell the point what mesh it should become, so you add the mesh as an attribute. Then you could also scale them up or down, rotate them, and filter out points you don't want. Now, to correctly select the foliage for my biome surface, I needed a way to tell the biomes what kind of foliage they can contain. So I will need to add my foliage data assets to the array in my biome data asset. These are the same foliage data assets I've been using previously, so no differences there. So now I just needed a way for my PCG points to access this biome data asset. Luckily, my voxel graph, where I already calculate this biome index, lets me store this biome index as metadata on the surface. So for every point in my PCG graph, I can simply sample this metadata to get the biome index. Then I can use the biome index to get the correct biome data asset, which then contains the array of all the foliage I can select from. Then, based on a weighted selection, I get one of these foliage assets and apply all the needed parameters from the foliage data asset to the point attributes. Then when I spawn the mesh, I read the necessary attributes to spawn the selected foliage, and bam, I get a nice forest. Or well, an okay forest, which is honestly kinda slow as it does a lot of work on the CPU side. But it's a start, and this also means that now I can get different foliage in different biomes. So to test out the modularity of this new biome-based foliage system, I modeled up some quick cacti in Blender. Once I had some cacti I was fairly happy with, I made a new cacti foliage data asset and put all my cacti meshes as possible variations of this foliage type. And then in my desert biome, I added the cactus foliage asset to the foliage array and regenerated my PCG graph. And there it is. Just by adding the foliage data asset to the biome, I get a desert full of cacti. So the modularity is definitely there. Adding new stuff is quick, but the performance of the system is still not where I want it to be. But I figured it was time to make a video anyways. Even though I'm not perfectly happy with the current solution, I still wanted to share some progress with you to let you know that I'm still working on Terra. So, since I'm not happy with it, what is the plan now? Well, recently I've been thinking more and more about making a completely custom solution for my entire planet generation and foliage framework. As you know, I've been using the voxel plugin to do the heavy lifting for a long time now, and it has served me incredibly well. But lately I feel like it doesn't really let me get the detailed control I want for Terra. And also this plugin is massive and it has so many nice features that makes it an incredible choice for anyone who wants to do basically anything with voxels. But in my case, I don't need the possibility to do everything related to voxels. I just need exactly the few features that Terra requires. And having everything else on top that I never use makes it kind of bloated, and I catch myself working against them all the time to make it fit into my system. And the same applies to PCG. It's designed to be universal and flexible enough to support almost any use case, which makes it a great option for all, but never the best option for something specific. I also realized that most of what I do is custom anyways, because I need to work around the limits of both the voxel plugin and the PCG when it comes to my own custom functionality. So the result was starting to feel like a Frankenstein's monster, like a forced combination of the voxel plugin ecosystem, the PCG ecosystem, and my Terra ecosystem, which just made everything so much harder to work with. And most importantly, I felt like I lost control over optimization, as I usually relied on the performance on the other systems. Like, if those systems didn't perform as I wanted, I was basically out of luck. And also worth mentioning, while I was having all these thoughts, people in my Discord were sharing their own experience with creating custom solutions to exactly the same kind of systems. So it's fair to say that this has inspired me and given me lots of motivation to try the same. So therefore I've decided to try to make my own custom planet generation and foliage scattering system designed around Terra. I'm truly looking forward to it, but it will probably take some time though, and a lot of research and many failed attempts. But in the end, let's hope I manage to create something worth the time. So that's my next task. Try to say goodbye to the voxel plugin and PCG, and say hello to my very own custom Terra system. And if you want to be here for that, make sure to subscribe to the channel. And also, if you want to discuss more game development stuff and follow the active development while it's happening, feel free to join my Discord server with the invite link in the description. That's it for now. I really hope you enjoyed the video, and if you did, a like would bring a big smile to my face. Catch you later.